In the previous videos, we discussed how to identify significant figures. And I'd like to take a moment and remind you that significant figures are a guide to the level of precision and the level of uncertainty that we have in our lab data. Most of the following problems have nothing to do with lab work. They're just simple practicing the rules of using the calculations with significant figures. However, this does answer the question that you've had in math class before, which is, how many decimal places do you want this answer out to? Well, there's actually a set of rules that tells you how many decimal places your answer should have. And the following videos describe the rules, and you will be using these rules throughout the rest of your chemistry and career, as well as any physics class you might take. There are two main sets of rules for calculating significant figures. The first set of rules deals with multiplication and division. So the rule is, the number of significant figures in the result is the same as the measurement with the smallest number of significant figures. Yeah, that's as clear as mud, right? We'll take a look at this first problem. First thing you want to do is say, hey, what does the calculator say? And you punch it in and you should get that number. Then the second thing you want to ask yourself is how many sig figs are in each of the two terms. So let's look at your first term, 4.2. And how many sig figs are there in 4.2? Yes, there's 2. Now look at the second term. How many sig figs are in the second term? Well, if you said 5, you would be correct. Now I'll just remind you about the 5. The 0 in the middle, that is a captive 0, so it always counts. That would be this 0 right there. And this 0 is a trailing 0 that appears in a problem that actually has a decimal point, so it is significant. The third thing you want to ask yourself is which of these two terms contains the least number of sig figs? Yeah, that'd be 2. Well, what this means is your answer can only be as good as that answer. So it too can only have 2 sig figs. Remember, we can't change the place value of this number. So this number still needs to be 35-ish of a number. Another way I could say this, instead of rounding this to 2 sig figs, is to round this to the nearest ones place. This digit's significant, this one's significant, but we don't need any of those. So basically, you're just taking 35.7 and rounding it to the nearest ones place, which would give us 36. That is our 2 significant digits and the correct answer. Let's try this one. Take a look at these 2 numbers. Yes, make sure you enter these into your calculator correctly. I did this type of problem for a reason. However, when you punch it into your calculator, you should get this number. The next thing you want to ask yourself is how many sig figs are there in each term? So in this very first term, how many sig figs are there? Yep, there's 2, because everything in front of the time sign is significant. And in the next term, there are 3 for the same reason. Well, which of these terms has the least number of sig figs? You guessed it, it's that one. So your answer can only have 2 significant figures. Without losing place value, how can I round this number to have 2 significant digits? What I'm saying is, how am I going to round this number so the 3 sticks, the 7 sticks, and I don't care about these. I want to round this to the nearest hundredths place. Well, the 6 says you do what to the 7? That's right. You turn it into 0.38. Oh my goodness, there's an error on this slide. Can you find it? Yeah, it says up here your answer should have 3 sig figs. No, it should have 2 sig figs, just like this answer that I've circled down here does. For these next 2 problems, get out your calculator, try the problems by pausing the video, see if you agree, and then play the video and see what happens. Our first problem says take 2.3 times 3.14. What are you going to get? Okay, so you've punched it into your calculator. What did you get? Being patient. Okay, so you should have gotten that this is equal to 7.222. This first term has how many sig figs? Correct, 2. This one has 3. So how many can your answer have? That's right, it can only have 2 significant figures. I care about this one, I care about this one. I cannot change the place value of these numbers, but I can round appropriately. Well, this 2 and this 2 I don't need, but you do have to pay attention for rounding rules. So your final answer, 7.2. Give this next one a try. Okay, when I did this problem, I got a final answer of $7.50. Whoa, is anybody out there going, I thought there was just one significant figure because of this 3? Yeah, you have to remember, how did you get that number of 3 boxes of candy? Didn't you get that number by counting? And when we obtain a number by counting, we say it has an infinite number of sig figs. So, one, it has an infinite number of sig figs, so it's kind of hard to count those. And secondly, we don't use these exact type numbers. We do not use them in our sig fig calculations. So the only number truly that became important was this number. This one has 3 significant figures. That's a trailing 0 following a decimal point. So our final answer should also have 3 significant figures. And it kind of makes sense. If a box of candy is $2.50, I'm certainly going to spend $7.50 for 3 of them. This next problem, go ahead and pause the video, see if you can come up with the correct answers, and then we'll see how you did. Okay, now that you've had a chance to try these problems on your own, let's see how you did. As soon as I find my pen here. Somewhere I should have a pen, looking for my pen. Oh, there we go. Okay, so here we go. We have the first answer, you should have gotten in your calculators, 3.98982. Boy, that's a lot of digits. Anyway, this first term has 3 significant figures. This term has 1, 2, 3, 4, 5 sig figs. So your answer, yep, it should only have 3 sig figs in the final answer. Well, that means I only care about these first 3. However, this 9 says I need to do what to the 8? That is correct. It rounds up. So we end up with 3.99 as our final answer. Now give this one a try. This one you should have gotten 0.0165513. Oh, I could just keep going. However, let's take a look. In this term, you should have gotten 2 significant figures. These are leading zeros. They never count. This term has 3 sig figs, so your final answer should only have 2 sig figs. Well, these are leading zeros. They don't count, so I'm really only interested in these 2. Now remember, these leading zeros are placeholders. You can't just ignore them. You just can't turn this tiny little number into 16 because leading zeros don't count. I mean, they do have a purpose. They're placeholders. There's 2 different ways you could write this number. The first one is you could keep the leading zeros. They won't hurt anything. 5 says to do what to the 6? Yeah, you got to round that up. Well, this number does have 2 sig figs, so you're good to go. Or you could have changed it to scientific notation and written 1.7 times 10 to the negative second power. Either one of these answers is awesome because they both show 2 significant figures. There. And now I totally don't know where I am. And so now I'm going to stop the video. We'll get back. Please give each one of these problems a try and see what you get. Make sure you pause between them. I'm going to work them along with you or after you or did them before you. It doesn't matter. I just want you to try them and then check your answer. That's what I'm trying to say. On this first one then, when you add these 3 numbers together, you should get 258 0.87. And this first term doesn't have, this first term is 1 decimal place. This one has 2. This one doesn't have any. So your answer, that is correct. It should not have any decimal places at all. However, that 8 says to do what? Correct, round it up. So we have 259. Give this next problem a try. And this one equals 38.2. Now let's see for sig figs. This term has 1 decimal place. This term doesn't have any decimal places, so our final answer shouldn't have any. The 2, well, good. I don't have to deal with anything because it's less than 5. Our final answer is 38. The next several problems are a mix of all of the rules to really test your understanding and hopefully answer any questions you might have. So you just basically, the directions are do the math and give me the answer with the correct number of sig figs. Again, pause it along the way, see how you do, and I'm going to be working these out and you can double check your work. All right, taking a look at this problem, then I end up with 0. I really like the 0 in front of the decimal point, by the way. Please write that 0. 107,744. Okay, this term, well, it's multiplication. So when we multiply and divide, what do we need to look at? Sig figs, yeah. So this term has 3 sig figs. This term also has 3 sig figs. Remember, leading zeros don't count. So because each of these terms has 3 significant figures, I'll go ahead and write that, 3 sig figs for each one, then our final answer should only have 3 significant figures. So I need to round this number to 3 sig figs. Your final answer is 0.108. Give this one a try, please. This problem then equals 116.47. Now, I'm subtracting. We have to follow the rules of addition and subtraction, which are different. These go by decimal places. So this first term, I'll try to say that, yeah. This first term has 1 decimal place. This term has 2 decimal places, so your final answer, 1 decimal place is the winner. Final answer then is 116.5. Again, any questions, make sure you jot those down so you can remember and ask me later. Problem 12. Same thing, it's a mixed bag of problems, but things are going to get a little more intense now. Give that one a try and see how you do. All right, this problem gives us, finding my pen again, let's use green this time. This one equals 0.006959. I do like that 0 in front of the decimal. Those are strange zeros. I'll try to fix that up for you. That didn't help. Okay, so let's find the eraser and we'll try that again. This number equals 0.006959. We are multiplying and dividing in this problem, so what do we follow? Which set of rules? Correct, we follow the rules of significant figures. This very first term's in scientific notation, so it only has 3 sig figs. This term, well, 1, 2, 3, 4, 5 sig figs and no zeros. This one has 2 sig figs, again, no zeros. So our final answer should have 2 sig figs. These leading zeros, they don't matter. There's 2 sig figs there. Make sure that these leading zeros, even though they don't count as significant, they are placeholders. So our final answer can be written in one of 2 ways. You could have written 7, 0. The 5 says you have to round the 9. This is a trailing 0. It appears after a decimal. I know. You're saying these appear after a decimal too, but they're still more leading than they are. This is a 0 that appears at the end of a number with a decimal present, so it is significant. The other way you could have written this number, anyone? Okay, well, anyway, it's 7.0 times 10 to the negative third would have been another good way to write this number. Okay, give that one a try. A good way to do a problem with a mixed bag, if you will. See, this problem has a combination of both types of rules. In the first part, in parentheses, we have multiplication. So we have to follow the rules with addition and multiplication, the whole thing. I said that strangely, I know, but you have to follow the rules of multiplication, which means follow your sig fig rules. Find a term or an answer. Actually, find the product is a better way. Find the product of these two numbers and then add to that the 8.41 following the rules of addition. So when you multiplied these first two numbers together, you would have gotten in your calculator 3.724. This first term has 3 sig figs. This term has 2 sig figs, so your final answer, 2 sig figs. So we only care about the 3.7. Now, when we add it to the 8.41, we are using the rules of addition. And the rules of addition say look at decimal places. This term has 1 decimal place. This term has 2 decimal places. So your final answer, 1 decimal place. You should end up with 12.1. This slide is an extra credit slide. You can work these out whenever you wish. Bring them in to me and I'll take a look at it. And the last slide is also extra credit. We're still going to practice speaking chemistry in. So in this case, write the formulas, bring them in, and let me see how you did. Those are your homework problems for tomorrow. I should stop calling them homework problems really and start calling them classwork problems. Those are the problems we'll be working on tomorrow. Have a great day.